Yeah.
Okay, so let's start here. Now in this case here, we have an inclined surface here, which is at 60 degree to the horizontal. Okay. We have something that's going to pull a load. Okay. The load is 50 kilogram. Okay. And they're going to go up another position, which the direction between this is 5 meters up the plane. Okay. Okay. So the question is, what is the work done by the winch? Example that just think that the winch is going to move this way. Now, in this case here, we need to know what is the energy given by the winch used to. Okay. So the work done here must be the same with the work absorbed by the mass. The mass is going to absorb the work in two things. First, in the change of potential energy. Okay. And then the friction. The resistance to motion here, 100 Newton, they need to overcome the frictions and also the change in potential energy, generally potential. Okay. In this case here, there is no change of kinetic energy. We think that the item here will be more or less the same velocity before and after. So the change in EP, we need to find out what is the height here. The height. So here we have m times g times the delta of h. For the friction, we're going to have the force times the distance that is being used. Okay, again, the potential energy is the mass times gravity times the gain of height. What is the height that's given? What is increased for the item? As for the friction, that's going to be simply the force times the distance. So we have 50 times 10 times 5 sin 60 degree. This is the mass times gravity times the change of height plus 100 times 5. The force times the distance. That's it. Any question for this one?
I'm still calculating first. Wait. All is in degrees, right? For this one, it's in degrees, right? Not in radians, right?
Yes. No. They say this 60 degree.
Wait, 5 sine 60. Okay, we got the and then times. Okay, got it.
Mm-hmm.
Which is 1 million. Wait, yeah, 1 million 82.
Mm-hmm.
1 million 82. 82,531. How is it? I don't know. 76.76.
Well, about the time. Okay. Let's see the mark scheme actually, so that we can get the idea what the item will be. Okay, that's going to be MS41.
So why did you have the 5 again, sir?
Sorry?
Why did you have 5 sin 60?
That is the height. Okay, the change of height here.
Oh. Oh, yeah, change in potential energy.
Mm-hmm. So
Okay, then may.
the P
Oh
increase.
yeah, I have calculation error. Never mind.
Mm-hmm. Okay, so 50 times G times 1560. So 50 times G times 100 plus 5. That's it. Apply the work energy equations 3 times. Okay, so we're using the second item here using the work only. That's mass gravity times F sin 60 plus 100 times 5. Okay, you
5
get
is the fraction coefficient.
Yeah, 5 is the distance that we do.
Oh,
Okay.
oh, FS. This okay.
Okay. Can you go to the next question? Or
Sure.
would you like to start again? I can start again if you want.
I think you can go to the next question, I guess you could say.
Okay. Okay. Here.
Sir, sorry. Why
Two.
why is the M50? Is it already times by half?
Sorry.
Dikali setengah ya. No, the M was already multiplied by half ya. Just now makanya 50.
No. The mass is 50. It's given, not
I thought 100 gram.
no 50. Why 100
Oh,
gram?
100 Newton. Oh, resistance. Okay.
That's difference. That's resistance. Okay, that's different item. Okay, so we have the Atwood machine here. Okay, actually we do have this machine in our physics lab. Okay. Two particles have masses m kilogram and 0.1, where mass is less than 0.1. So this one is heavier. The particles attached to the end of flat inextinguishable string. Okay, the strings pass fixed smooth pulley, and the particles hang vertically, both 0.9 above horizontal. The system relays from rest, and both particles are in motion. The tension is string is 1.5 Newton. Particle B does not reach the pulley. So this B here did not reach that. We are going to find M. Okay, this is the Atwood machine. Okay. If you want to get them here, what we do is we are going to divide them into their forces. Okay. For particle A, because the mass is more than 0.1, we know they're going to go down, right? B is going to go up. So A is going to go this is going to be positive. For particle A, the acceleration here is going to be weight, which is mass A times the gravity. And we have the tension there. I'm going to write them here. Sum of the forces for particle A is okay, mass of A, m, times the gravity minus the tension. Mass of A times gravity times 10 minus tension, that is going to be mass times A times the acceleration. Now, in this case, we know that the tension is going to be 1.5. So we can calculate them here, that mass A times 10 minus 1.5 is going to be mass A times the accelerations that we don't know yet. Okay. For B, okay, the B is going to go up. So the T here for B is going to be positive, while the weight of B, which is going to be mass B 0.1 times 10, which is going to be 1 Newton, is going to be negative. For B, sum of the force of B, T minus 0.1 times 10. Okay. That is going to be mass B times acceleration. Okay, so we can find out here the value of acceleration. The value of acceleration is 0.5 is 0.1 a. So acceleration is 5. We can use this value to here and calculate what is MA. MA times 10 minus 1.5 is 5 MA. So 5 MA is 1.5, and A is 0.3. Okay. Let me try it again. Okay. Let's start at B. For A, because they are going to be heavier, A is going down and B is going up. So for A, this is positive. Mass A times gravity is going to be positive force, and the tension is negative force for A. For B, B is going to go up. So the tension is positive for B, and the mass B times the gravity, the weight of B, is going to be the negative force, because it's going to try it going down. For B, sum of the force of B, read that T minus the weight of B is going to be mass B times acceleration. Let's put the number. 1.5 minus mass of B is 0.1 times 10 is going to be 0.1 times acceleration. 0.5 is 0.1 A, hence A is 5. We know the acceleration of the system now. Now that we have acceleration of the system, we can check what happened in A. In A, sum of the forces in A says the mass of A times gravity, this is the force forward, minus the T backward equal to mass times acceleration. Put the number. Mass of A times 10 minus 1.5 is 5 times MA. Rearrange. This and this taken together become 5 MA, become 1.5. So MA is 1.5 over 5 or 0.3.
Sir,
Ta-da!
sir, I want to ask, sir, why the
Yes.
tension here is in some of the forces of B is positive, while in some of forces of A the tension is negative.
Okay. In this case, think of them as a group. A and B here is going to work as a group because they are connected by the rope, right?
Yeah.
Because A is heavier, more than 0.1, we know that A is going to go down, where B is going to go up.
Yeah.
So in this case here, for A, going down is positive. So the force, the weight of A is positive with respect to A, because the weight of A make them forward. The tension from the point of view of particle A is negative because they're going to get them backward. So for A, because A is going down, the weight is positive, but the tension is negative because A is going down. But for B, if you are in B, for B, the tension is positive. It makes it forward for B. But the weight of B is negative because it tried to give, it pulls it backward.
So that means if the particle is going down, that means the
Yes.
tension will be negative, while the mass will be, well, the weight will be positive. But then if the
Yes.
particle is going up, the weight will be negative, but then tension will be positive.
Yes.
Okay, got
The
it.
direction, your direction determine which one's positive, which one's negative. If you go up, then whatever pushes you up is positive. Whatever pushes you down is negative. For A, forward is weight, backward is T. For B, it's the other way around. T is forward, while weight is backward.
Okay, then I got it. Thank you.
Okay, welcome. This is a classical question here, and a lot of variations, okay, will be given here. Okay, can I erase this one?
Sure thing.
Okay, let's have the next one here. Find the speed at which A reached the ground. Okay, now let's see here. What do we know about A? For A here, we know the initial velocity is going to be 0. Okay, because the initially they say release from rest. Okay. And we know the acceleration of A is going to be 5. We know that from the previous one, right? From the previous calculations, the acceleration is 5 meters per second square. And we know the distance is going to be 0.9 meter. Okay. What is asked here is the speed at which A reaches the ground, which is, that's going to be the V. Okay. What is missing here? What's missing is T. So among the 5 equations of mechanics, equation of motion, find the equation without T.
Is it the V
That's
square?
going to be
V squared equals to
okay.
U square plus
Correct.
2AS.
Yes, very good. And after this, all you need to do is just put the number in. Okay, so it's going to be 0 square plus 2 times 5 times 0.9. It's going to be 9. So V is 3. So the particle A is going to hit the ground here with the velocity of 3 meters per second. Okay, clear enough?
That's simple enough, I guess.
Yes, this is the usual 3 plus 1. 3 data, 1 question. And this can simply be solved if you memorize the 5 equations of motion. That's it. Okay. Next question. 3 particles, P, Q, R, are at rest in a straight line on a smooth horizontal plane. Particle P is projected towards Q at speed of 5 meters per second. After P and Q collide, P rebounds with speed 1 meter per second. Find the speed of Q immediately after collision with P. Okay, so here we have P and we have Q. Okay, at rest. Okay. At a straight line on a smooth horizontal. Then this is projected, okay, at the speed of 5 meters per second. Okay. Now, what happened after this? They are going to collide, right? After the collision, P is rebound with 1 meter per second. What will be what happened to Q then? Okay. Classical question here, this is going to be the case of momentum. Okay.
Sir,
Total
sorry, I just realized, are you the one making the test paper or Mr. Lexi? Because you're the one know what we studied in math, right?
Mr. Lexi will have to.
Oh, okay.
Okay, so in this case here, as usual, collision, speed, and velocity, that's about momentum. The total momentum before must be the same with the total momentum after. Okay. Before, with particle P being 0.1 and particle Q being 0.2, the momentum of P is 0.1 times 5. Positive because going to the right. And the momentum of Q is 0.2 times 0 because they are at rest. So it is going to be 0.5. This is the total momentum before the collision. After the collision, the momentum of P is 0.1 times negative 1. Why negative? Because it's to the left. While the momentum of Q is going to be 0.2 times V. We don't know what is V, but we know the total. The total is going to be 0.5.
Wait,
Okay, up until this?
anything. You haven't written anything.
Oh, really?
Yeah.
I've written a lot actually. Wait. Okay, maybe something. Wait, yeah. Let me share again. Okay, I think the previous one. Okay, we have P and Q. Okay. P and Q. Particle P is moving towards Q with the velocity of 5 meters per second. Q is 0 meter per second. It's not moving. Whenever we have two items colliding, we have momentum, right? So we are using the formula. Sum of the momentum before is the same momentum after. Before, what's the momentum? The momentum is 0.1 times 5 for P plus 0.2 times 0 for Q. Okay, that's going to be 0.5 plus 0 or 0.5. This is the total momentum. After the collision, the total must be the same. What happened after collision? After collision here, the P moving rebound means to the opposite directions, to the left. The P is now negative 1 meter per second. Negative because the direction is changing. The velocity of P we don't know. Let's call them V of P. We can calculate their momentum. The momentum is now 0.1 times negative 1. Rebounds means change direction, plus 0.2 times V of P. But the total has to be 0.5. The total must be the same. Okay, so let's calculate this. Negative 0.1 plus 0.2 VP is 0.5. If we put them the other side, 0.2 VP is 0.6 and VP is 3. So the speed of Q is 3 meter per second. Okay, after this, any question?
So that means momentum.
Yes.
So that means momentum is like energy potential, right?
Similar, but not exactly. Momentum is momentum. They have a different unit, different dimension.
What is the unit of momentum?
Kilogram meter per second.
Oh, kilogram.
Mass times velocity. Kilogram meter per second.
Okay. So that, and then for that means the formula for momentum is the weight, the mass times
Velocity. That's it.
Oh, my mass times velocity. Okay.
Yes. Okay.
Thank you. Wait.
Mass times velocity total before, the same with mass velocity total before. That's an easy 3 marks, I think. Can I erase?
Yeah.
Okay, good. Okay, next. Q now collides with R. Immediately after collision, R begins to move with the speed V meter per second. Okay. Okay, now let's have the condition here. Okay. Now what happened is we have Q moving to the right with the speed 3 meter per second. And the R here. Initially, R is not moving. Okay. So the same thing here is the same condition happens before and after. We need to find the total momentum before and the total momentum after must be the same with the before one. We know the mass of the Q is 0.2 and R 0.5. So
Okay.
the momentum of Q is 0.2 times 3. That's the momentum of Q. Plus 0.5 times 0. Why 0? Because we know they are going to not move initially. So that's going to be 0.6. Okay. Afterward, okay, we have them here. The R moving that way, the Q moving that way. Q and R. No subsequent collision between P and Q. How come? Well, it can be if the Q velocity is not higher than P. We know that before, P is moving here with the speed of 1 meter per second, right? In order to make sure that Q is not going to collide with P, the velocity of Q maximum is also 1 meter per second to the left. Okay. More than that, eventually Q is going to hit P. Okay. I repeat, if Q is not going to hit P, then the velocity of Q may not be greater than the velocity of P. P going to the left 1 meter per second. Q may not be faster than that. Because if Q is faster, eventually it will catch P, right? So the velocity of Q, we're going to set the same 1 meter per second also. Okay, so we can calculate this one here. It's going to be 0.2 times minus 1, negative 1 because to the left, yeah, plus 0.5 times V. That's going to be 0.6. Must be the same before and after. Okay, let's solve this. Negative 0.2 plus 0.5 V is 0.6. Okay, so 0.5 V is 0.8 and V is 1.6. Okay. Up until this, any question?
No, sir. Wait, sir,
Okay.
but then for momentum, like, are there like
Yes.
keywords for like the question that indicates that's momentum?
Collision.
Collision.
Whenever you have collision here, you get the, okay, this is going to be momentum.
Collision is keyword.
Yeah.
Okay, thank you, sir. So that we know
Welcome.
what to do.
Okay, can I erase this one?
Sure, don't worry. And sir, also, the time is only 8 more
Yeah.
minutes. Should we rejoin or what?
Okay, you can rejoin if you want.
Okay, I want to rejoin.
Let's, okay. I'm going to go to the next question, yeah. Okay, two cyclists, Isabel and Maria, having a race. They both travel along straight roads with constant acceleration, starting from rest at point A. Isabella accelerates, so let's say they are, wait. Let's say in this case, they are starting at the same position. This is their starting position here. Okay. This is Isabella and this is Maria. Okay. They starting from the rest. Let's say this is point A. So initial velocity is 0. Isabella accelerates for 5 seconds at constant rate a meter per second. Okay. Then travels at constant speed she has for 10 seconds before decelerating to rest at a constant rate of a period of 5 seconds. Okay, so let's say we try to make the graph velocity over time. For the first 5 seconds, they're going to go constant. The acceleration is a. Okay, and after this, let's say the velocity that she has is going to be 5a. That's going to be the velocity she has after 5 seconds. Then she's going to go constant for 10 seconds. If this is 10 seconds, we have at 15, right? Okay. Travels for 10 seconds means it's 15 seconds. This is going to be 10 seconds. And then decelerating, okay, to a rest at a constant rate over 5 seconds. So after 5 seconds, after the 20 seconds, it's going to go back here. So this is what happened to Isabella. Isabella start at 0, okay, accelerate for 5 seconds, stay the same for 10 seconds, and then decelerate again for 5 seconds. Okay. Up until this, any question? No? Okay, now what happened to Maria? Okay. Maria here, they accelerate at constant rate, reaching speed 5 meters per second in this distance 27.5. Okay. So in this case here, we are going to have Maria going 27.5 meter. Here, the area is 27.5 meter for Maria. Okay. The speed is 5 meter per second here. Then maintains for 10 seconds. If she maintains for 10 seconds, the distance she cover is going to be 50, of course. Okay. Before decelerating to rest at a constant rate for 5 seconds. Okay. If for 5 seconds, she is going to decelerate, the area for this one is going to be 12.5. So we know for Maria, it's easy for us to find out the distance.
Sir,
Distance is the area under,
I want
yes.
to know, where do you get 12.5 from?
Oh, the area of this triangle is height times base over 2. 5 times 5 over 2.
Ah, okay, okay. So the
Yeah.
area beneath
forget.
the line is the
Mhm.
distance. Okay.
Yeah. For the velocity to time graph, area under the graph is the distance traveled. So total for Maria, it's going to be 27.5 plus 50 plus 12.5. That's going to be 90 meter. That's for Maria. Okay, what is Isabella? Why is it? Okay, sorry. For Isabella, okay, we are going to concentrate at A meter per second for 5 seconds. Okay. 5 seconds. So the velocity is going to be 5A. Then we are going to go for 10 seconds. Okay. With the velocity 5A times 10 is going to be 50A. 50A meter. Okay. While the area under the graph is now 12.5A. Then we are going to decelerate for another 5 seconds. So the area under the graph here is going to be 12.5A. 5A times 5 over 2. So the total area is going to be 12.5 plus 25, 25, 75A. Okay. This is for Isabella. Any question for this one?
I want to ask, sir. So that
Yes.
means for velocity, this is velocity
Mhm.
time graph, right?
Mhm.
And then
Yes.
so that means there's an A. So that means for to find velocity, that means it's the time times acceleration, right?
Yes, times accelerations. The V is U plus AT. When the initial value is 0, so V is just A times T. Accelerations time time.
Okay, then. Thank you.
Okay. Now, for question part A. Given A is 1.1, which one travel faster? Okay. So for this one, we can multiply this by 1.1 and we have 82.5. So Maria travel faster.
So that means if we draw graph, we already got point, right, sir?
Yes.
We draw graph. For example, we draw a graph. We sketch a graph here. We get also already like a point, right? Or two.
Yeah. Let's check how it says. Then. Okay. So the constant speed for 10 seconds here. Correct expression. Usually, if you draw the graph, then this one is implied there. So mostly the marker is going to give you mark. Okay, but the mark itself here is to find out the data that you have them there. Okay.
I think we can rejoin. This is already like.
Oh yeah, less than 1 minute. I'm going to close this room for now.